Hello everyone. Today we'll be discussing about a problem from nbpho 2015, that is problem number 6. Problem number 6 says the following is a snapshot. Depicts two balls that were thrown simultaneously and with same initial speed but in different directions from point P. P is the throwing point. This is the coordinates of first ball and this is second ball. What is the initial speed? The goal is to find the initial speed of the ball if they were thrown with the same initial speed but with different directions. Now the thing to discuss is the core motive behind the problem. So what is the approach to solve this problem? Let me explain. Suppose this is point P, that is the throwing point as shown in the figure. The first projectile is thrown with speed u1 and second is with speed u2. First one reaches a point, let us call it q, after some time t. In the same time, the second projectile reaches q dash. One thing it's clear that mod u1 is equals to mod u2, and since they were thrown at the same time and the snapshot is taken at the same time, so t1 is equals to t2 is equal to t. We know the second equation of kinematics, that is S is equals to ut plus half at square. In 2D format, we can write S vector, that is a displacement vector, is equal to u vector t plus half g vector t square, where g vector is minus gj cap. This is the core formula required in the problem. This u vector t is nothing but denoting this one. This whole is u1 t vector, and half gt square is nothing but this half gt square g vector. Now I assume this one to be q1, and similar for the second projectile, this is u2 t vector and this is half gt square. This is q1 dash. The key observation in this question is the q dash 1q is equal to q1q. Q dash 1q dash is equals to q1q. This means that the both vectors are same in magnitude as well as in directions. Thus we can say one thing, means that q1q is equals to q1 dash q dash. This means that suppose we shift point P by half g vector t square. This is the core manipulation involved in this problem. Then we'll get half g vector t square plus, this will be half g vector t square. Then if we draw a line to q and to q dash, this u2t vector is parallel to the line p dash q dash. Similarly, p dash q is parallel to pq1 line, and we already know that u2t mod is equals to u1 t mod. That is why we can say one thing, that p dash q dash is an isosceles triangle. Now how to find this point p dash? We know that in any isosceles triangle, suppose ABC, where AB is equals to AC, if we draw a perpendicular bisector of BC, it will intersect at vertex A. Thus, if we draw a perpendicular bisector of QQ dash, I am showing using a green color. If we draw a perpendicular bisector of QQ dash, it will meet at point PP dash. It will meet the point P dash, and this way we can find a point P dash, and we can derive PP dash is equals to half G vector T square magnitude, which is simply half times 10 times T square. Okay. Then measuring P dash Q, we will get UT. P dash Q will give me the value of UT. Substituting T from the first equation, we'll get U is equals to P dash Q by T, and that will be our answer. Let me show you the manipulation related to this problem. Okay, so I have brought the page of the drawings I made regarding this problem. Let me show you the manipulations. So this, I have considered an x-axis and an y-axis. I have drawn lines along the g vector to find the y-axis, and line along this 10 meter line to plot the x-axis. Now this, when I use the paper, 10 meter was coming out to be 4.4 centimeter using scale, since it's given that this length is equal to 10 meters. Here P is the throwing point, and this is the coordinate of ball 1, and this is for ball 2. Here I have connected this line 1 2. Just a minute. I have connected this line 1 2 and drew the perpendicular bisector of line 1 2 using the compass, which will, I guess, intersect the x-axis at some point. Supposed I have taken it to be Q. I measured PQ, which came out to be 3.9 centimeters, and a surprising result which I found was that Q intersected the x-axis at the perpendicular foot of perpendicular of P on the x-axis. This was a surprising result for me, and I found it a little interesting and got motivated to solve the problem, that probably I was heading towards the correct direction. Then I found the distance between point Q and ball 1, which came out to be 11.3 centimeters, this distance. Yeah. Now next thing is, we already said that PP dash, in previous diagram I took it as PP dash is equals to half G vector T square. So I can say that half GT square is equals to PQ. Now since 10 meters is equivalent to 4.4 centimeter, so 3.9 will be equivalent to 10 into 3.9 by 4.4, which came out to be approx 739 by 4.4, and putting G is equals to 10 meter per second square, time came out to be 1.38 seconds. So this is our first equation. Now as I measured Q, distance between Q and 1 to be 11.3, so 11.3 into 10 by 4.4 is equals to U times time, but time is equals to 1.38 seconds. Substituting the values, we'll get U is equals to 19.97 meter per seconds, nearly, or you can also say it 20 meter per seconds, and that's the answer. Hope you enjoyed the video. Thank you. Have a nice day.